In this lesson, we're going to be discussing Cayley Hamilton Theorem. So what does this theorem state? It states that every square matrix satisfies its own characteristics equation. Now let's consider this matrix A and then find its characteristics equation using this formula, determinant of A minus lambda times identity matrix equal to 0. So we're going to have the matrix A is given as 2, 4, 3 and 1, then minus lambda times 2 by 2 identity matrix equal to 0. Let's not forget the determinant and symbol. So let's perform this operation. Again, we have 2, 4, 3 and 1, then minus lambda times 1 is lambda, lambda times 0 is 0, lambda times 0 is 0, lambda times 1 is lambda. Then this is going to be equal to 0. Then we have 2 minus lambda, something as 2 minus lambda. 3 minus 0 is equals to 3. 4 minus 0 is equals to 4. 1 minus lambda is 1 minus lambda. Then this is equals to 0. So let's find the determinant of this matrix. So you have 2 minus lambda times 1 minus lambda. This is 2 minus lambda multiplied by 1 minus lambda. Then minus 3 times 4 is equals to 12. Then this is going to be equals to 0. 2 times 1 is equals to 2. 2 times minus lambda is equals to negative 2 lambda. Negative lambda times 1 is negative lambda. Negative lambda times negative lambda is equals to plus lambda square. Then minus 12 is equals to 0. Now 2 minus 12 is going to be equals to minus 10. Then minus 2 lambda minus lambda is equals to minus 3 lambda. Then we have plus lambda square equals to 0. Rearranging this, we're going to have lambda square minus 3 lambda minus 10 equals to 0. So this is the characteristics equation of this matrix. Now let's apply the Cayley Hamilton theorem on this characteristics equation. In applying it, we're going to replace these lambdas with the matrix A. So it's going to be equal to A square minus 3 times A minus 10. Now if you look at this, we see that we have A here, which is a matrix. We also have A here, which is a matrix. And then this 10 is a scalar. So we can subtract a scalar from a matrix. So because of that, we're going to multiply this negative 10 by an identity matrix. Alright, so this is now going to be equals to 0. So Cayley Hamilton states that if you substitute this lambda with this matrix A, then if you simplify this, we are going to get 0. So that's what Cayley Hamilton theorem states. So let's simplify this and know if we are going to get 0. Now A square is given as this is 2, 4, 3 and 1. A square multiplied by 2, 3, 4 and 1. Then minus 3A, which is 2, 4, 3 and 1. Then minus 10 multiplied by identity matrix, which is 1, 0, 0 and 1. Two times 2 is 4 plus 3 times 4 is 12. I have 2 times 3 is 6 plus 3 times 1 is 3. Then 4 times 2 is 8 plus 1 times 4 is 4. Then 4 times 3 is 12 plus 1 times 1 is 1. then minus 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 1 is 3, minus 10 times 1 is 10, we have 0, 0, and 10. This one will give us 4 plus 12 is 16, 8 plus 4 is 12, 6 plus 3 is 9, 12 plus 1 is 13, then minus 6, 9, 12, 3, minus 10, 0, 0, and 10. So let's perform these operations. So we have 16 minus 6 is equals to 10, 10 minus 10 is equals to 0, so we have 0 here. Then 9 minus 9 is 0, 0 minus 0 is 0, 12 minus 12 is 0, 0 minus 0 is 0, 13 minus 3 is 10, 10 minus 10 is 0. So as you can see, we have verified this Hamilton theorem, which states that every square matrix satisfies its own characteristics equation. So this is the proof.